Hello, friends. We are going to go through this first area of logic in the Kalam Cosmological Argument. When we were in class to get together, we talked about the Big Bang Theory and whether or not it's helpful or harmful to Christianity. And if we're looking at the cosmological argument, the Kalam version of the cosmological argument, we have to first answer this question. Did the universe begin or did the universe not begin? Was the universe always here? And so if we are starting with this question, then I think we see that the Big Bang Theory, at least in its basic premise, is actually really helpful for Christianity for the following reason. It's one of the first steps in the Kalam cosmological argument that the universe had its origin in some sort of cosmic explosion into existence. Now, I'll unpack this idea a little bit further after this section, but I think the first thing that we need to establish, where you're going to get the most pushback from people in regards to the Kalam cosmological argument, is whether or not the universe began. People might just say it's always been, but if you can establish that the universe began, then it's only like a couple of really quick hop, skips, and jumps to get to the existence of a God. So here we go. The beginning of the universe. Scientific data seems to point towards a beginning to the universe in the finite past, meaning at some point in the actual past, the universe started to exist. And there's 5 pieces of evidence that all point towards this beginning in the past. The second law of thermodynamics, the expansion of the universe, the cosmic background radiation, great galaxy seeds, and Einstein's theory of general relativity. One of the things that people use to describe this is they call it surge. Second law. Universe, radiation, galaxy seeds, and Einstein. Surge is a way that you can memorize these 5 things. Cool. Now, here are some of those scientific issues with an infinite past. The second law of thermodynamics says that in any closed system, there is entropy, meaning that there's less usable energy, right? So the scientific issue with the infinite past in this case is that the universe is still going. Here's why this points to a finite past. If there is only a finite amount of energy that is usable in the universe, what this means is that if the universe went on forever into the past, by the time we got to now, it would have forever to run out of energy before we get to now. And if that's the case, then we should have run out of energy by now. Let me say that one more time. This is like a weird thing to think, right? If the universe always existed, if there is an infinite past, the fact that we still have energy today would be a problem. Because if an infinity of past needs to happen before getting to now, then what that means is that we should have run out of a finite amount of energy. If there's only a limited amount of usable energy and we had forever to use it, that means we should have been out of it by now. So, second law of thermodynamics, the fact that we are running out of usable energy, is the first problem with saying that the universe has an infinite past, or a past that goes on forever. Now, the second problem with an infinite past is the expansion rate of the universe. So the universe is space and time, like those 4 dimensions. The universe is slowly expanding. We can tell this because as we look at objects in space, when things are moving toward you, they shift blue on the light spectrum. And when they're moving away from you, they shift red. Nearly everything in the universe that we observe is moving away from everything else. Imagine, that's what this circle inflating is. Imagine if you drew a bunch of dots on a balloon. It's not like there was a central point and everything's moving from that central point, but rather, as you inflate a balloon, all of those dots continue to get further from each other. And this is actually what we are seeing as we look through telescopes in the universe. As we look at the light spectrum, we are seeing things move away from each other, meaning that it is expanding. And what happens if you reverse this? It goes down and down and down and down and down and down and down until you get to a finite point in the past where it gets infinitely condensed and small. So, we have usable energy. That's a problem with an infinite past. The universe is expanding, meaning that would shrink down to a finite point in the past. The next thing is cosmic background radiation. When we look at the radiation in the universe, there is like the equivalent of what would happen if you're playing one of these first-person shooter games and you throw a flashbang. After you throw a flashbang, your vision goes white and there's like shaking, and there's like a little bit of residual trembling. When we look at the cosmic background radiation, it's kind of the same thing not the same, kind of the same thing, but like the same concept is we look in the cosmic background radiation and there's still like ripples in the radiation that indicate like some sort of huge universal explosion in the finite past. And I know galaxy seeds is related to this, but it's not exactly the same thing. But galaxy seeds are like these irregularities in that background radiation that like allowed for the galaxies to then form. And so both of these things point towards some sort of like cosmic release of energy or explosion in the finite past. The last thing is Einstein's theory of general relativity, not special relativity, that's a different thing. But his theory of general relativity helped us to prove that time and space, as we know it, time and space are linked. So this is why if you watch Interstellar, there's all sorts of weird stuff with time. If you, like, as they get closer and closer to gravity, because or a black hole, because the gravitational force works like an acceleration force, and time and that space like affect each other, right? If that's the case, then the existence of this universe is tied to time in a way. And so if we're talking about the beginning, like a point in the finite past where the universe burst into existence, where it all started, then what we also have acknowledged is that time also started. It wasn't like you had a forever. It's not like you had an infinity of time to pass and then all of a sudden the space happened in matter and energy, but rather time itself started in the finite past. And so that's the other thing about, like, if we're talking about the expansion rate of the universe, it's not like at the Big Bang. It's not like at the beginning there was empty space and then boom, something exploded. But rather space itself started to exist at a point in the finite past. I know this is crazy. So space itself and time itself and matter and energy, all of it started at some point in the finite past, and the scientific data seems to point us to that conclusion. Now, if science isn't your bag, we can do some philosophy. Oh, by the way, that's, I believe that's the cosmological constant symbol, which is the thing that like points towards like this factor that had to be taken into his calculations. Anyway, there's also philosophical problems with an infinite past. Philosophically, logically, the universe can't go forever into the past. So here's a way that we can like kind of unpack this idea. So imagine you went to IKEA, like you do, and then you get to the end and you get your box where there's all of these instructions on how you're supposed to put together your table, right? And you're following these instructions to put together your table. If you open the book and you realize that there is an infinity of instructions that you have to complete before building your table, will you ever build that table? Well, if you think about it, no, because how many instructions would you have to complete before building the table? An infinity. You'd have to do an infinity of instructions before having a table. You will never have that IKEA table. Another way of looking at it is dominoes. If there's an infinite number of dominoes that need to be knocked down before getting to this last one right here, will that last domino ever fall? Right? If there's an infinity of dominoes before this domino, if you can go back in domino time, in infinity, will this domino ever fall? No, because how many need to fall first before it gets to this domino? Infinity. And you will not ever get to infinity. So if that's the case, I want you to imagine that each of these dominoes, or each of those instructions in the IKEA example, either the instructions or the dominoes, whichever works better for you, each of those, I need you to imagine, is a moment in time. So you can give whatever measurement you want, a second, an hour, a day, a year. But Before this moment, there was a moment before that, and a moment before that. So let's do years. There was a year before that, and a year before that. Let's say centuries. There was a century before that, and a century before that, and a century before that. If we do millennia, or we do millions of years, let's do billions of years if you want to. They go back far enough. But what if I said before this current moment, there's an infinity of years? Let's think about that for a second. What would be wrong with the idea that there's an infinity of years, an infinity of moments before this moment? If this was true, if there was an infinity of moments before this moment, like it's the same as the dominoes. This moment would never happen if an infinity of other moments need to happen first. This day would have never happened if an infinity of days needed to happen first. You see, that the problem with the infinite past is that if there's an infinite amount of past moments, we will never get to the present moment, right? There has to be a finite beginning in the past. And so the Big Bang, I would argue that the Big Bang is actually one of the best pieces of evidence for a God. The Big Bang is actually an amazing piece of evidence for the existence of a God. And note that I'm not saying how the universe began. Like that's not what we're saying when we say the Big Bang. We're just saying that the universe began. And the fact that the universe began is huge evidence for the case of the existence of a God. And what we'll do together in class is we'll have to talk about, well, what could cause a Big Bang? We'll have to discuss that. All right.